and garlic, which is not really a fabulous thing to do. So we want to synthesize these compounds instead of actually extract them. And so what we are going to do as technicians in this pharmaceutical lab is we're not going to synthesize these specific compounds quite to the point that they're at, but we're going to synthesize the analogs, the precursors to these compounds. That's what we're looking to do, okay? So just keep this in mind as the goal of the project, because when we get to the end again, we'll have to remind ourselves of what we were actually trying to do, all right? So to do this, we've got three steps, hence 3 parts of an experiment along the way to do this. So you guys, this week, we'll start with 4-hydroxybenzoic acid, all right? Everybody is starting with the same thing, okay? But what you will vary, and we'll talk about how that works out here in a minute, is you will be using different alcohols to use the Fischer esterification to convert our acid to an ester, okay? So that is the first step. We want to go from carboxylic acid to an ester. In the second step, we then want to convert our phenol side using an acid chloride to an ester as well. So in the end, at the end of next week, you will have created a diester, all right? And then what we're going to do is use enzymatic hydrolysis and try and figure out which enzyme and which configuration of esters works well to get to the desired compound, okay, or the desired analog that's the precursor to the desired compound, okay? So this is kind of our 3 steps. And so how that breaks down, because we're adding all this variation to this project, is a table like this. So this is the information that we gave you guys last week. We gave you technician numbers, and we told you that you were going to need to know what you needed to do in the first step and how that was going to vary. So in the first step, which is this step A column, so you know what number you are, right? Everybody's got that number, okay? The first column tells you what alcohol you are using this week, all right? So our possibilities are methanol, ethanol, and 1-propanol. So if you have a methyl group there, then you're going to use methanol. If you have an ethyl group here, you're going to use ethanol. And if you have a propyl group, you're using 1-propanol. So then you know what alcohol you're using, okay? Next week, we're going to vary what acid chlorides we're using for the second step, for the second the formation of the second ester, all right? And so we'll talk about that next week. But as far as what you need to prepare for next week, this will give you the information for which acid chloride you're using. So the methyl is acetyl, the ethyl is propanol, and the propyl is butyryl. So you, with the acid chlorides, we'll talk about it next week, but you basically add on 1 carbon, okay? And then the final step, we're going to vary what enzyme you do for the hydrolysis reaction, okay? So we'll use either orange peel esterase, which comes, like, it'll be prepared from orange peels, or pig liver esterase, which luckily we don't have to prepare, and you can actually buy the actual enzyme, okay? So those are the 3 steps and how to read across your technician number to figure out what you are doing each week, all right? So is everyone clear on that and that table? Okay. So the reason we did this is we wanted to add variation to this experiment to be able to figure out what our best conditions were. And so in the first step, we've got 3 possibilities. In the second step, we have 3 possibilities, and in the third step, we have 2. So that gives us our 3 times 3 times 2, which is our 18 different technician possibilities, all right? And so those of you that are in a lab that have more than that, then we're doubling up a little bit on some of the technician numbers. But that gives us at least 18 possibilities to look at all of these different reaction conditions and different diesters we make, and then using a different enzyme, what are the best conditions, right? So for this week, we are going to look at using the Fisher esterification, okay? And so that's what, ooh, he's falling off now. I'll get to this mechanism here in a second. So the Fisher esterification, where we are going to use, in our case, this carboxylic acid, but in general, what you usually use for Fisher esterification is a carboxylic acid. So here's ours, and you react it with an alcohol to then form the ester. And this is Fisher, a person's name Fisher, so keep that in mind. We capitalize our Fisher, okay? So we react with an alcohol, and we go on to get, I'll give ours is designated as R prime here. This would be the type of product that we would then produce, all right? Now there's a couple things we have to keep in mind with this reaction. When we go through the mechanism here, we'll show that it's actually acidic conditions. The acid we're going to use this week is sulfuric acid. And this arrow here is not actually a really nice straight to product arrow, but we've got a nice equilibrium that sets up, okay? And so we have to push our reactants to the products, all right? So one of the things that we're going to do is our alcohol, whoops, wrong one. Alcohol is our solvent as well. So we're going to put lots of reactant in there. So if you remember from Gen Chem, if you have a lot of stuff on this side, you want to push it over there, okay? So we're going to use our alcohol as our solvent. So there won't be another solvent for the reaction, it's just the alcohol that you're using, all right? We are also going to try and minimize water as much as possible in this reaction because water is going to send it the other direction because we actually end up making water in the end, okay? So we don't want to have a buildup of water because it'll send it back the other direction. So we use concentrated sulfuric acid, so be really careful handling the sulfuric acid. It is concentrated. You don't want to get it on yourself. Wear gloves with it, okay? Keep it in the hood, and if anything's spilled, let us know. We'll get it cleaned up. So we want to minimize as much, the least amount of water possible with the acid. And then when you're running the reaction, make sure what you're using is dry. You don't want to add water to your system. Make sure you have everything clean and dry for the reaction. Now the other thing with this reaction is there's only certain alcohols that really work. So the possibilities that we gave you are the really good ones. We could also throw butyl in there, but what we want are straight chain alcohols, okay? We start, like if we use isopropyl, isobutyl, things like that, it's not really happy with that as far as the mechanism is concerned. And the longer the chain of the alcohol gets, the less reactive it is and the more time it takes. So we didn't incorporate butyl in these possibilities because it just takes too much time for the time you have in lab, all right? As it is, we're going to let these reactions go for 2 hours at reflux. So that's pretty much the maximum amount of reaction time we can have in lab, especially at reflux, because you've got to get it up, heat it up, and all, then still have time to work up the reaction. So people who use methanol will probably get better reaction conversion with methanol than they will with propanol, just because we don't give it as much time to react, whereas the methanol is going to react quicker, okay? All of these products will give a whitish solid, so that's what you're looking for. Over here is some white, kind of somewhere between white, yellow, solid, or off-white solid. So keep that in mind when we get talking about the workup. We have to remember that our product is white off-colored, or off-white color, and one of the things we're going to do is use magnesium sulfate to dry the organic layer. So we have to remember to keep our product and magnesium sulfate separate. So for the mechanism, and have you guys got to covering esters quite yet in lecture? Just started? Okay. Have you done Fisher esterification yet? No. Okay. Well, it's very soon. Very, very soon. Okay. So I'm previewing reactions for you guys again. But you'll cover it very quickly here. So we have our carboxylic acid is in a solvent and solution that is acidic because we're adding the sulfuric acid to it. Okay, so this whole reaction is taking place in a situation where things are all acidic. All right. Because of that, we can use that acid to protonate the oxygen of our carbonyl. Okay, and so then that makes that carbon more susceptible to then react with the oxygen from the alcohol. All right, and so we get our carbonyl oxygen is protonated. We get attack from the oxygen of our alcohol at the carbon of our carbonyl, and we get some movement of our electrons up to our oxygen. So we get this tetrahedral intermediate. All right. Now what we need to get rid of something again to reform the carbonyl to end up with our ester. And so what works pretty well here is to be able to have a proton transfer, because this isn't necessarily the greatest leaving group and we don't want all this leaving, but if we can make a water, then we've got a good leaving group, right? Recall water is one good avenue to have something leave from your intermediate. So we've got a proton transfer here, and that's like, we've got protons all around. It's really easy for it to happen because our solvent here is acidic. We've got acid in there, okay? So we get this proton transfer, we've got water ready to leave, and then we can kick down our electrons, reform our carbonyl. And then we just made water, we can use that as our base to deprotonate our carbonyl here, and then we form our ester. And we talk about this being catalyzed with acid because here we go, we form our H3O+, we've reformed our acid again, okay? And so all of this is occurring at equilibrium, so as much as we could do to push the equilibrium, the better off our results are. So again, that's why we're using the alcohol as our solvent, and we want to minimize how much water is in the reaction, okay? So we talked about this is going to be done at reflux for a couple hours, okay? And the reaction itself, we're going to reflux with a heating mantle. Now what you don't want to do is just kind of cook the heck out of the reaction, okay? So you want to gently reflux with a heating mantle. And those that have methanol, you're going to have to heat at a lower, use lower setting on your ohmite than ethanol and then propanol. Okay, so it depends on what alcohol you have as to how much you need to turn up your ohmite. But get it to where it's just refluxing. So we don't need just like, totally refluxing out of control. Just nice reflux. Because this takes 2 hours, we're going to have you guys come into lab this week, set up your reaction, and then we will take the quiz. So the very first thing you will do in lab this week is come in and set up your reaction, get the reflux going. So we've got that clock already started for the 2 hours as soon as possible. And then once everybody has a nice reflux going, then we will start the quiz, all right? And that will also help use up our 2 hours that you'll be waiting, because then we'll do all the other stuff we need to do during that 2 hours, all right? So when you come to lab, be ready to go, ready to set up your reaction, all right? So know what alcohol you have. In your pre-lab, you want to set up your pre-lab for the alcohol that you're using. You're going to have to calculate how much alcohol you need. When you're doing that, do you want that in grams or volume? What are you going to measure? How are you going to measure the alcohol? Volume, right? So make sure you have it calculated in volume, okay? And be ready to go setting up your reaction, okay? The ethanol and the methanol is just our red can ethanol and methanol, okay? So that is where it will come from. The people who are using 1-propanol, it'll be in the reagent deck for you, all right? Okay, so that's just the reaction itself. Then what we need to do is we're going to remove the alcohol, okay? That people with methanol or ethanol, you're going to use a simple distillation. Just because with that acid in there, we don't want to cook it any more than we did with the reflux. So we don't want to use the heating mantle to distill it. Okay, we want to use well, we're going to do a simple distillation, and we want to use a hot water bath. Okay. So you'll remove it with a hot water bath. The people with propanol are going to do this with gentle heating. We don't want to heat on it too much. You're going to use the rotary evaporator to remove propanol. Now that sounds like the propanol people are getting off easy, but it will take about as much time to get all the people that have propanol rotovap down as it does for all of the people that have methanol and ethanol to use a simple distillation to get rid of it, okay? So it's not going to save the propanol people any time at all using the rotovap. It's going to take some time even with the rotovap to remove the propanol because it's high enough boiling, okay? So it's not like you guys are getting the short end of the deal with the methanol or ethanol, all right? So simple distillation, we're going to remove the alcohol. Then we need to dissolve the residue in ether. And the reason for that is just that is our solvent for our workup, okay? And then we're going to go through a series of washes to get rid of things that are still in our reaction mixture, okay? So the first thing we're going to do is we've got 2 by 25 milliliters wash with water, and that's going to help remove a lot of the sulfuric acid that is present, okay? Because we haven't done anything to make it not acidic, all right? Now remember from experiment 8, what does wash mean? What are all the steps involved in wash? So we've got our mixture already dissolved in ether. We're now going to wash with water. What are we going to do? What do we do? What apparatus are we doing this in? Step funnel. We're going to add our ether solution, right? And then we'll add one of these portions of water, right? And then what do? Shake and bend, shake and bend, shake and bend. Okay? And then what do? Drain the aqueous layer, right? So that is all one step of washing involves all of those pieces, okay? You'll put in your ether layer into the step funnel, you'll add the water, you'll cap it, you'll carefully shake and bend, shake and bend, shake and bend, let the layers settle, and then remove the aqueous layer, okay? So you will go through that twice with just water, all right? Then we're going to do a 1 by 25 milliliter wash with 5% sodium bicarbonate. What will that do? Why do we need to do something basic? will help us remove any residual sulfuric. Okay. What else will it help us remove? Think about what we're starting with. Okay. Will sodium bicarbonate help us deprotonate this proton? Yes, right? And get it into solution so that we can remove any remaining starting material. Okay? So, we're using this to remove residual sulfuric acid and remove residual of our 4-hydroxybenzoic acid, which we call this is our starting material for the whole sequence. All right. Then we've got one more wash. With saturated sodium chloride solution. This helps remove remaining salts and a little bit of the water out of the ether. Helps drive water more towards the aqueous layer. Okay. It doesn't get rid of all of it, but it does help get rid of a little bit of water, a little bit of get rid of the residual salts and a little bit of the water. Okay, so now we get down to our drying with magnesium sulfate. So what is that used again for? We'll put it in our ether layer, right? We're going to dry the organic layer with our magnesium sulfate, okay? How much magnesium sulfate do you add? Free floating, and that you have some clumping with a little bit of free floating, right? Okay. Make sure that you have, like sometimes the ether will evaporate on you too, so if your ether layer is looking pretty small, add a little bit more ether so you can see the magnesium sulfate in that ether, all right? And you'll add the magnesium sulfate so you've got enough free floating and some clumping and a little bit of free floating. Swirl it really well, cover it with saran wrap, let it dry for about 10 minutes, and then how do we filter it?
Gravity filtration.
Gravity filtration, okay? This is where we have to be careful. Some of the products, especially the people that have the used methanol, your product looks a lot like magnesium sulfate, okay? And it'll want to crash out on the magnesium sulfate. So after you dry with magnesium sulfate, when you're filtering, make sure you rinse with ether. Rinse that magnesium sulfate with ethyl ether, or you will end up getting your product to crash out on the magnesium sulfate, and you'll think it's magnesium sulfate, but it's actually a product, okay? So be really careful with, once you dry it, make sure you rinse that solid with ether to get all the product down into the filtrate, okay? So then all we have to do is remove our solvent. What are we going to do? What do you think would be the best way to do this? Rotavac. Yes, that will work well. So, sorry, I didn't even send it up that far. So we use the rotary evaporator to remove the ether. What's a good idea before whenever you go to Rotavac with your round bottom, so you know how much it weighs? Tear the round bottom flask, right? Okay, and then just like we did last week, we'll use the high vacuum pump to remove residual solvents. So there's number of steps in our workup to get down to our final product, all right? And then you can just store your product in the round bottom flask that you rotovapped in. What I would do is not use your 50 ml round bottom flask because you're going to use that next week. I believe that's the one we use. We'll double check. It's either your 25 or your 50. So look ahead to part 20B before you rotovap and see which flask you need for part B. Don't use that one, okay? And then you can just store your product in the round bottom flask with a grease stopper. Couple things you need for your product, okay, before you store it. We're going to need to collect our yield, okay? We're going to need to prepare an NMR sample. And you're going to need to collect an IR spectrum. Those things we need to do, and we need to try and get those done this week if at all possible, because Tuesday labs are going to have something due on Friday, and Thursday labs will have something due on Monday, okay? The other thing that's mentioned in your lab manual is you can prepare, so these are our like need to do's. You can prepare a TLC vial of part A if you have time. If you don't have time to do this, don't worry, we can get that together next week, okay? Where you're gonna take just a little bit of your part A product, put it in a vial, and next week we'll add ether to it so you can use it for TLC. If you don't have time to do that this week, we can take care of that next week. But make sure you get these 3 done this week, all right? Okay. Now for your notebooks, we're gonna treat things a little bit different for each of these steps than we have before with multi-step experiments, okay? So for each step, these are the pieces that you are going to need in your notebook, okay? You will have a pre-lab that is specific for each step. So for part A, the pre-lab you are preparing is just for part A, okay? You don't have to do all of experiment 20. You're just preparing the pre-lab for part A this week, all right? So you'll have pre-lab, you'll have experimental, and then you'll have what we call a mini conclusion. And this is just a paragraph or 2 highlighting the results. What were the yield? What was the percent yield? What information did you get from the Nmr Spectrum? Does it look like the product is in there? What does the IR spectrum look like? It's just the very basic results. Do they look good, and can you go on to the next step? Okay, so that's what you're putting in that mini conclusion. So discussion on mass, discussion of NMR, discussion of IR, can you move on to the next step, all right? And you want to complete this before you start the next step. So you want to have your mini conclusion. You'll have your pre-lab in before you start. You'll have your experimental in as you go. You want to have your mini conclusion in your notebook before you start part B next week, okay? Yeah?
2 questions. I'm guessing the mini conclusion is typed?
Nope, it can be handwritten.
Okay, and do you want us to, like, for the NMR, make our tables?
It's a good idea to put them in there, but you don't have to have like perfect tables in there yet.
Okay.
Is what I would say. If like specific questions like that, I just clarify with your own lab prof just to make sure. But for my students, a general summary of the NMR and the IR is good enough. Touch on the high points. Like if you made the methyl ester, you know, are all those peaks present in the NMR? That's that sort of thing. Does the IR look like it should and match what the product should look like? Yes?
Okay, so on the board right there it says report for part A due this week.
I haven't gotten there yet.
Okay.
It's coming. So this is just your notebook. This is not the report yet, okay? This is just what is going to go in your notebook. So make sure, like you'll have this before you start again. Experimental is going to be in there. Make sure your mini conclusion gets in there before you start next week, okay? All right, any other questions with this part before I go on to the next piece? Okay, so that next piece is in your lab manual is a report sheet for experiment 20A. Okay? So you are going to fill out this report sheet, all right? Draw the structure of whatever which was your specific compound, give all the information, yield, percent yield, what is your technician number. And then there is information you have to provide about the IR spectrum, and then you also have to assign the peaks in your IR spectrum. So the IR you collect on that spectrum, make sure you assign the peaks. And then you also need to produce an IR table, okay? For the NMR, you're going to have the NMR spectrum. So we'll gather your samples together, run your samples, then you have to process your data. On the spectrum, you will follow these instructions for what you need to put on there, draw the structure, label all of the peaks. And then make sure you answer here the question about the spectrum. If you have any extra peaks, what are they? And is there any reason to continue to, not to continue to 20B? And in with the NMR, just with the, like with the IR, make sure you have an NMR table too. So IR table, NMR table, assign peaks on the spectra. And you will attach your spectra to this report form, okay? So your report for 20A is this report form and your spectra analyzed with the IR table and the NMR table, okay? So there's not really, besides answering the information here, there's not really any more writing that is due, okay? But keep in mind, for what is due, you need to make sure it is all done really well, okay? Because the biggest, besides filling out this form, what you're being graded on is how well did you analyze your NMR spectra and your IR spectra. So think of things like, are there extra solvents in there? What are the extra peaks in there besides the product? Make sure you label TMS, make sure you label chloroform. Make sure if you see any residual ether in there, make sure you label that. Is there any starting material still left in there? If there is, make sure you label those peaks. So be very thorough in your analysis of the NMR and the IR, because that's what you will need to be able to do for getting full credit for the report. Question, did I answer it? Okay. So that is your report. Is this report form with your IR, your analyzed IR, and your analyzed NMR spectra attached, and make sure either on the spectra or separate attachment is the IR table and the NMR table. Yep.
When is this
Monday for you.
So Tuesday labs, this is due on Friday, or the Tuesday lab, it's due on Friday. The Thursday labs, it's due on Monday the 3rd. Okay? So you don't have a huge amount of turnaround. The reason that we have you do this is to make sure that the product that you have produced is good enough to go on to the next step, and it won't cause you issues going on to the next step. So that's why we're having you turn this in now versus, you know, later on. We need to check your data and make sure everything looks okay for your data so that you are good to go on to the next step. Yeah. Well, it depends on, like, it just depends on what's in there. Like, sometimes people just have, like, extra solvent. So we tell you to bring in your, you know, come in and put your stuff on the vacuum pump and use the vacuum pump longer or something like that. Like, I have never told a student you have to start over. We'll figure it out, okay? But a lot of times it's things like that, or maybe we need to do another water wash, or maybe we need to do some, you know, something else. But I have never told anyone to start over. Yes?
The week of break, are we having lab?
So next week, yes.
The week after?
But the week after winter break, when we miss Tuesday, we won't have Thursday.
So then we're
So next week we'll talk about the deadlines for B, but it gets extended a little bit because of winter break. This one's the tight one because we don't have much time in between. Yeah.
For the quiz this week, would it just be on part A or is it on all of it?
I would say understand the general project, like the general idea to the experiment. But as far as the details of things, you're going to look at 20A. And so each week we'll be looking at each part. Okay. All right. So here, I'll write this on the board too. So your report form and analyzed IR and NMR spectra. And with that, like, it's really important that you also make sure on that report form it asks for the yield. It's really important you do accurately report that, because in part of the figuring out things is we also have to figure out, do you have enough material to go on to the next step? And if not, is there someone else that we can borrow from in the lab to make it work, okay? So make sure you do accurately report your yield on that report form. But this will be due, so for Tuesday lab, so used to lab, it's due Friday. So tomorrow in my lab, we'll talk about exactly when that is due, which is still February, or January, not quite February. So the 31st, that is due. For the Thursday labs, it's due on Monday, the 3rd. Okay? And so in lab on Thursday, all of you that have someone different than me, make sure you find out from them exactly when time frame that's due on Monday. All right? That's pretty much all I have for today. Questions you guys have? Good? Okay.